Good evening from Dhaka. This is our AS and A-level chemistry lecture series, and this is 44th lecture. And we are talking about benzene and its derivatives. The last lecture we had, the last slide, we discussed about addition reaction of benzene and talked about how we can have an addition reaction, showed how we get cyclohexane from benzene and how a free radical reaction can be done, forming 1, 2, 3, 4, 5, 6 hexacyclochlorohexane. Now we are in this lecture, 44th lecture, we'll be taking another few examples of derivatives of benzene, and that is phenol, and its functional group is OH. Here it is. This is the formula of phenol, and that is the functional OH is the functional group. And phenol is at room at 43 degrees Celsius is crystalline solid. Okay, and this OH group gives hydrogen bonding in phenol, and therefore it's has stronger intramolecular forces than that of benzene. OH group in phenol allows hydrogen bond with water. As a result, phenol dissolves slightly in water and more readily in alkali, such as sodium hydroxide, which forms soluble ionic compound. Here is soluble ionic compound. It forms soluble ionic phenols with sodium hydroxide. Okay. Phenol can be prepared also from phenylamine. That's phenylamine. How we do it? We use nitrous acid and keep it in lower temperature and using ice to keep the temperature below 10 degrees Celsius. That gives us a unstable diazonium salt fast. And then we unstable diazonium salt fast. This is the diazonium salt. And then we react this diazonium salt with water and we get phenol and hydrochloric acid. We can also see that we can introduce other group, that means let's say nitro group in phenol by reacting with nitric acid, or even other group like methyl group or nitro group here. So we can prepare 2,4,6 trinitrophenol, or we can prepare 2-methyl-5-nitrophenol, or we can prepare 4-bromophenol. Next slide. How we prepare phenol industrially. So there is a statistical data that only UK manufacture each year about 100,000 tons of phenol. So if we want to do industrial manufacturing phenol, we have to go with a procedure, we call it cumene process. The raw materials is benzene and then propene. Here is propene. This is benzene and propene. So in acidic media, we've got acid catalyzed electrophilic substitution of benzene with propene to form cumene. Hence, this is cumene. And then it's oxidized in here and we get phenol. Phenol plus propane, propanol. This is propanol, this is phenol. Okay, now reaction phenol. As you said, we can prepare bromophenol. Here with aqueous phenol and aqueous bromine, we can prepare bromophenol and hydrogen bromide. With phenol and nitric acid, we can prepare 2-nitrophenol. We talked about it. And we can also prepare 2,4,6 tribromophenol. This was 2,4,6 tribromophenol. And then we talked about 4-nitrophenol that we can put for dilute nitric acid. Remember that we need to have dilute nitric acid. Okay, we now go to another compound of benzene. We start with first methyl, and then aryl, we go to aryl. Yeah, you see, amines. What is amines? It's the nitrogen compounds which have one or more hydrogen atoms in ammonia. Hydrogen ammonia. Note that we have to remember one thing, and that is we have been discussing about primary, secondary, and tertiary compounds of some of halogen alkanes or alcohols. Here, when we're talking about amines, we have also been using this. For example, methylamine, we call it primary amine. This is methylamine. You see, that is the NH group. And then hydrogen is replaced by a methyl group, and that we call methylamine. It's a primary amine. If we replace 2 hydrogen by 2 methyl group, we call it dimethylamine, you see. And then also it is secondary amine. So, and if it is 3 methyl group, we call it tertiary amine or trimethylamine. Tertiary amine. But it is not like that we replace hydrogen from carbon atom, you see. We are replacing nitrogen. So there is a difference between primary and secondary, tertiary halogen alkanes and alcohols, that of amines. Okay, so the simple naming of amine is combination of the alkyl or aryl groups followed by ending amine. So here is alkyl groups. And then we have amine, we call it butylamine, you see. It is butyl, and then amine, butyl. There this benzene in here, and then amine group, and we call it phenylamine. Similarly, we have this one is a ethyl amine, ethyl methylamine, and we can use prefix di, tri, etc. when we are calling about same alkyl group or aryl group. Okay, name this amino is used in compounds that have second functional group. We call, for example, that this is amine, and then we have a second functional group here. This is acidic group, so we call it aminoethonic acid. We can use also diamino functional group. Also here, this is amine group, and this is another amine group, and there we can call it 1,2-diaminoethane. Okay, next slide. How to prepare amine. First, let's talk about how to prepare a aromatic amine. We go for that first, because we are talking about benzene. We had many discussion about I would say methyl or ethyl group amine before, but now we are concentrating ourselves in aromatic amine. And no, how do we do that aromatic amine? It is two-step process. What we call first we introduce a nitro group. Here is benzene. We are introducing nitro group. What we do, we take concentrated nitric acid and concentrated sulfuric acid, and the reaction temperature is around 50 to 60 degrees Celsius. And then the first step, we introduce a nitro group there. We call it nitrobenzene then. And then what we do, we take this as the second step of the reaction, that we reduce this in presence of a metal. We can use tin as a metal in concentrated hydrochloric and heat it. And then that nitro group is reduced to, and then we get phenylamine. Okay, here is the laboratory method. What we do, we take our nitrobenzene here and then add tin and this reflux it, we get then the phenylalanine. But note it, you have to note that tin is expensive metal than that of iron metal. We can industrially use cheaper metal, that is iron metal, to produce phenylalanine. When we primary amines can also be prepared by reducing aliphatic nitriles. This is an aliphatic nitriles, what we call butane nitrile, and then we reduce this butane nitrile to get butylamine. Also, we can have a reducing agent, lithium aluminium hydride, ethoxyethane. This is an ethoxyethane, and we reduced it with lithium aluminium hydride and get aliphatic amine, butylamine. Okay, now we go for physical properties of amine. And what is the simplest amines are similar to those of ammonia. For example, methylamine and ethylamine are gases at room temperature and they smell like ammonia. The fish has got ethylamine and therefore we get a fishy character of the smell. Propylamine are butylamine liquid at room temperature. Like ammonia, alkylamines dissolves readily in water because they can form hydrogen bond with it. Phenylamine is said also that it can it is because of non-polar benzene ring. It is not slightly soluble in water, not like not like alkylamines. Its arylamines are slightly soluble in water. Okay, what about strength of ammonia? That means how do we see? This is methylamine, which is stronger than that of ammonia, which is also stronger than that of phenylamine. And then we can say primary amines, we can act as a Bronsted-Lowry acid. If you remember Bronsted-Lowry bases, we defined it in other lectures. The lone pair of electrons in nitrogen, that is lone pair of electrons in nitrogen of ammonia or amines is a protein acceptor. We can get the reaction with water, that if we react with water, aqueous ammonia with water, we get ammonium ion and hydroxyl ion. If we take butylamine, we can see that we get butyl ion, ammonium ion, and amine ion, and then hydroxyl ion. And if we take phenylamine, react with water, we get phenyl ion and hydroxyl ion. Alkyl groups are electron donating or electron releasing. And there we showed how the electron nitrogen lone pairs gets drawn to the delocalized ring of electron, thereby stabilizing it more. Okay, now we go for next slide. And here we start the reactions of ammonia with acid. So here, amine with acid, sorry, not ammonia, amine with acid, ethylamine reacts with hydrochloric acid, then we get ethyl ammonium chloride, And then butylamine reacts with hydroxide, we get butyl ammonium chloride, you see. So phenylamine is slightly soluble in water, but it also dissolves in hydrochloric acid but easily, and therefore if we get phenylamine and with acid, we get phenylammonium ion. Phenylammonium ion, if a strong base with sodium hydroxide, it also reacts and we get phenylamine back and water. So this is what one more thing we have to remember, that we will have complex ion. In transition metal chemistry, we did discuss about complex ion with D block elements, such as, let's say, copper. if we have copper aqueous solution, and if we react with phenylamine, we get copper phenyl aqua ion. And then we have to remember that this sort of ion, we say tetraamino copper 2 complex ion. This one, tetraamino 2 copper complex one, tetraamino copper. Here you see that we please do remember that we use amine, amine, but in organic compounds, when we are talking about amine, we say amine. Please know these two differences. In complex cation with amine or ammonia, we do read it like this: tetraamine copper 2 complex ion or compound. So, okay, now we go for some reaction with halogen alkanes. This is what is halogen alkanes, is it not? So we are reacting phenylamine with halogen alkanes, and what we get? What we see, we get this ion, this butyl methyl ammonium bromide, butyl methyl bromide. Then this, when we react this, then this goes to this proton, and then we get this butyl methylamine. Similarly, we can replace this one methyl with replacing one hydrogen, then second methyl replacing another hydrogen, and similarly we can get this. All the hydrogens are being replaced. So here you see that all the hydrogens are being replaced by methyl group. We call it butyl methyl tetraaminobromide compound. If we do this. Okay. Now we do talk about amides. You see, you do have amines, amides, phenols. These are the aromatic compounds we are talking about. I said that we can have aliphatic amide also. And here we are talking about amides, but then we continue to aromatic compounds. So amides are a derivative from carboxylic acid, in which amine group replaces the OH ion, one of the OH ion group. So one of the OH ion of carboxylic acid is replaced by an amine. The chemistry of amide is important. Why? Because this monomer we can prepare or can produce proteins by this monomer. Then or we can say that amide is a monomer of proteins. We know protein is very important for our medical reason, for our body and biological system. So we can prepare proteins and in synthetic polymers, and also synthetic polymers like nylon and Kevlar. This group is also found in many medical drugs. So that's why amide is a very important compound for us. Amides are named using the suffix amide. Similarly, what we did, you see, this is the general structure of amide. This is the general structure of an R and C double bond and C NH2. But this is the functional group of amide. That's what we are talking about. We replace one of the hydrogen by an OH group. So this is the functional group of amide. And then we name this one that ethane. When we start naming, we have to use this carbon chain and taking the carbon also in the consideration of the functional group, and then we name it. So here it is ethane amide. Here, if we can see that this one of the hydrogen has been replaced by ethyl group, so we can N-ethyl propanoamide. So you see the structure of ethanamide and also an ethyl propanamide. This is the structure. So with the help of this structure, we can also write down the structure of butanamide or N-methyl pentanamide, hexanamide or N-phenyl ethanamide. So how we prepare amide then? One more thing we have to remember, that we need not to confuse amine functional group, which has no carbon double bond oxygen group, which is no carbon this group, which know that if we have amine group, we don't get this group in the functional group, but if it is an amide group, we do get this carbon oxygen double bond in the functional group. Do you remember this? This is what we have to remember. Okay, how we prepare this then? We take ethanol chloride, this is what ethanol chloride, and then react with ammonia, we get amide, ethanamide, and then hydrochloric acid. We use this hydrochloric acid and ammonia and get ammonium chloride. It's a very reactive compound. Even at room temperature, we get amide and vigorously reactive with one. So ethyl chloride, if we take ethyl chloride carefully and add it concentrated aqueous ammonia solution, we get a vigorous reaction, including producing fumes of hydrogen chloride, ammonium chloride, such as, and then a residual ethanamide. Paracetamol is an N-substituted amide. Paracetamol is an N-substituted amide. Okay, we go for amino acid. And with this one, we'll finish our lecture for today. That is 44th lecture. And we continue with the 45th lecture in the next week or so. Amino acids are also an important group of compounds, and that this is what is structural formula of an amino acid. What you get? This amino acid has this basic amino group and an acidic carboxylic group. So here is the basic amino group in the same carbon atom. We are having basic amino group and then acidic carboxylic group. These two make amino acids. The amino acid is amphoteric. What is amphoteric? It behaves both as an acid or base. That is what we call amphoteric acid. When an acid behaves both as acid as well as base, depending on condition, we call this amphoteric substance. An amino acid is an amphoteric substance. Okay, then one type of amino acid is bonded to carbon. This I mentioned, bonded to carbon atom, and then carboxylic group also. We call this one 2-aminocarbolic acid, and this is what we mentioned before, building blocks of the proteins. These amino acids are the building blocks of the proteins, and then there are at least 20 naturally occurring amino acids. That is, so we have to know how to name these amino acids. Then simplest amino acid is glycine, systematic name, aminoethanoic acid, and which R, this R has been replaced by H, and this is what is the simplest one. This is aminoethanoic acid. Okay, if we replace this R with this methyl group, we call amino acid. This amino acid is named as alanine, and the simplest one is named as glycine. So its acidic part of the amino acid is the carboxylic acidic one. Basic part is an amine group, and the neutral part is the alkyl group. So We talk more about amino acid and things like this in next lecture. And thank you very much for attending this lecture. We hope to see you in the next lecture. Thank you.